I must say, before I proceed any further, if you are not comfortable in any way by dealing with electrics and electronics, have a qualified electrician do this for you. If you screw up, damage to property, serious injury or death can occur. So you have been warned, just in case, okay? So with that scary warning out of the way, welcome back to Libus Custom Knives. This is part 4 of building our heat treatment oven. And today we'll be overviewing some of the parts we will be using to wire up the oven, as well as construct our control box. So without further ado, let's get started right away. Right, so the first thing you're going to need is a power cable. Okay, what I'm using over here is this. This is a power cable designed for the 13 amp power supply. Okay, it's got a detachable end, and of course I've also got the socket for it as well. So I can plug my kiln in, and if necessary I can detach it just like that to make things nice and simple for myself. It's got a 13 amp fuse, and the connector itself is rated for, I'm pretty sure you can see it, 16 amps, okay, at 250 volts. So that's the first thing. Okay, the second thing is various cables and of various descriptions for wiring things inside and outside of your kiln to the control box and back out. For example, this is a 3-core 2.5 mil square cable, okay, that I'm going to use quite a lot. And these over there are audio quality connection cables. I think the brand is, there we go, let's make sure it can focus on this, Van Dam. Okay, and they should be pretty good in case I need to extend any signal cables or anything else. Okay, another thing you're going to need is wire crimp connectors, something like this. I got this from Halfords, and of course wire crimp pliers as well to put them on. Next comes the glass fiber rope. We already talked about this in the previous video. You're going to be using this to create a better seal on around your door. Okay, this is a very heat resistant rope that doesn't melt and just can simply be nailed or stapled in place. It's quite soft. Get the soft variety as well, not the hard one. Okay, and can be used to create quite a good seal around your door. A couple of steel metal gang boxes. Okay, they're normally used for attaching power switches and power sockets and whatnot to the walls, but we're going to use them to protect any exposed live electric currents from in the back of the oven. I got 2 because they are very cheap, and just in case I screw one up. Next thing in the list is a couple of computer cooling fans. Okay, I got 2. I'll be using one to push the air out and the other one to pull the air in to the control box, because quite a few components actually generate some heat in there, and they need to be cooled in order to operate effectively and to prolong their life. Okay, also get some grill protectors to prevent any stray fingers actually going into the spinning blades. Just get the cheapest ones you can find. Okay, they'll be perfectly fine. You're not concerned with your kiln being particularly quiet, I bet, and you don't need a lot of air coming through them. Just the cheapest ones you can find. I got those on eBay. Another thing is something like these, like this. Most people will have this laying around their house. It's a 12 volt power supply. This particular one can do 12 volts at 500 milliamps. We will use this to power our fans and some other lights or whatever we may have installed into our kiln. It's solid state relay. Basically what this is like your regular relay, but with no moving components. So the PID computer, which we're going to talk about in a moment, is going to give it a signal, and then this is what controls the power to the heating elements. Mine is a 25 amp SSR, solid state relay, that's what it stands for, and it can the input can be from 3 to 32 volts and the output is anywhere from 24 to 380 volts AC. Okay, you want to be sure that the output is that the actual coil voltage is whatever you're going to be using it, and make sure you, even though the limit on our sockets is 13 amp, I'm effectively doubling it with this because I want this to live as long as possible, because this is really what's switching the elements on and off, on and off, on and off all the time. Okay, so this is going to go for a lot of strain, as well as it generates quite a lot of heat. So you want to make sure you get some sort of a heat sink for it. That's another reason why we have the fans. Okay, they will make sure we cool these as quickly as well as possible, because we want this to live as long as we can. And however, it's not that expensive. I got this on eBay as well. Actually, both of these. Another thing is these. They are ceramic cable connectors. You want to be using the ceramic ones, because these are the ones that are going to go in the back of the oven where things are potentially going to get hot. So the plastic ones are going to melt. Okay, I got 3 just in case I need them, and I got these off of eBay as well. Right, another thing is an M6 thread rod. You've seen this before. I use it to make the pin of my door interlock, and this is in stainless steel. Ideally, you want to be using stainless steel fixings inside of your oven, because it's gonna get really hot in there. Okay, as well as stainless steel nuts and stainless steel washers as well. Okay, you're gonna see in a minute, in future videos you're gonna see how we're gonna be using them. You want to be using a switch. Okay, this is a regular 15 amp at 250 volt switch. Basically this was going to be the master switch to turn your oven on and off. This particular one is illuminated, but that's not necessary. You just want to be able to see a light whenever the kiln is on. Okay, also there's a circuit breaker. I didn't want to mess around with fuses, because it's just, if there is a short circuit, it's just going to get really messy, and you have to replace a disposable fuse. Basically what this does, this is a 15 amp circuit breaker. So if there's anything that goes wrong with this, if there's anything wrong in your circuit and there's a short circuit for some reason, this should trip the circuit, and as opposed to blowing out the entire power supply for your house, which is always a good thing. Another thing I have over here is a warning light that I bought. There we go. This is a 230 volt one, so it just runs off the mains power. I wanted this to give me a good positive light whenever the elements are live or can be live. Okay, so basically if I open my kiln door and this stays on, I have to be very careful, and there's something wrong with the circuit, so it's going to give me a very good indication of what's happening. Talking about that, there's this. This is a tiny micro switch. You may be able to hear it clicking on and off. Okay, what this is, what we're going to be using it for is we're going to use this as a door interlock. So effectively, once the door closes, it presses the switch and allows the current to flow through. This way we'll ensure that whenever our door is open, the elements cannot go live. This is very important, okay? Because if they can go live, and if they are live when you are opening the door in your oven, sooner or later you're gonna kill yourself. It's as simple as that. And this is where this comes in as well. This is a relay. Okay, its coil is a 12 volt DC, so obviously it can run off the power supply that we had just a moment ago. Also, it can switch 250 volts at 12 amps. Okay, you may want to get a larger relay than this. However, this should work perfectly fine for us. Okay, it's a double pole relay, so we can switch off both the live and the neutral wires at once. That is quite important, because you never know. You want to be switching off both wires at once, because if there's a cock-up in your circuit somewhere, it could be that you've got the live and neutral mixed up, and as such you think you've disconnected it, but you really haven't. Okay, so you need something like this as well. This is important. This is not optional. Another thing over here, this is a switch. Now, perhaps a missile toggle switch like this, the fighter jet style toggle switch is a bit dramatic, but I wanted something that cannot be accidentally bumped on. Okay, so there's a reason why it has a cover, and that means that it can't be accidentally bumped on. You actually have to do 2 actions to turn this off, and you can very quickly disable it as well. What this is going to do, this is going to be a final switch for the power between the door interlock and the relay. Okay, so this is what's going to control sort of the final failsafe, whether we turn the heating elements on or not. So I can power down, for example, if it is on, I can power down the heating elements without turning the whole oven off or without opening the door. That will come useful when we have our oven built. A clamp style multimeter that can measure AC current is useful, however not necessary, but you may want to be using this to measure how many amps your oven is drawing, just in case it doesn't perform as well as you expected, so it will help you troubleshoot whatever's wrong with your oven. Also, I don't really think this is optional. A multimeter, just regular kind, is something you're going to need. Also, it's really useful if it can measure temperature as well. You may want to double check how effective your kiln is by measuring the outside temperature as compared to the inside one. Okay, so this is, I don't think this is optional. You really should have this. Everyone should have one of those. Okay, and various connectors are useful as well. You're going to be needing those. What this is, it's a new trick. Just try to get an angle right. There we go. It's a Nutric PowerCon Type B, this particular one is. It's a brilliant connector. I'll be using this to take the power from the control box to the elements. Okay, and the way this works, after you've assembled it, you put them together, twist it, and it locks itself into place. You can't unscrew it out afterwards, so you can't pull it out either. You actually have to pull this locking lever out, and then you can twist it a little bit, and then you can pull it out. It's a great little connector. I'm really impressed by the quality of something like this. There we go. That is the model number of this particular connector. Okay, it's really great, and make sure you get the socket to match as well. Another thing I got, but I'm not sure if I'll be using it, is this. This is your regular XLR, I believe they are called. I believe they are called XLR connectors. They are used quite a lot in the audio and video style of business. For example, to connect microphones to mixers and things like that. Originally I got this in order to connect my thermocouple to the computer. However, I did some tests, and as it turns out, you really want to be running your thermocouple direct, okay, without using any connectors or even the good audio cables I showed you earlier ago. This has been told to me actually on the British Blades forums as well, that you're not to use anymore the connectors aren't the problem. The problem apparently is using different metals. As you can imagine, the thermocouple uses a particular combination of metals. Then you'll be transferring them onto the copper, which is in your cable. Then from the copper you'll be transferring them onto, well, in this case, silver, which is what's inside. These are silver plated. Then from silver you'll be transferring them onto gold, which is because these contacts are gold plated. Then from gold you'll be transferring them back onto copper, and then it's going to come back into your computer. I tried that, okay, I ran a test, and the thermocouple then said that my body temperature was about 20 degrees centigrade, okay. I'm pretty sure I wasn't dead at that point, so I'm simply going to be wiring hardwiring effectively my thermocouple into my PID computer. Now, you can get specific plugs and sockets for thermocouples. They are also color coded, and they have to be particular to whatever thermocouple you're using. For example, if I'm using the Type N thermocouple, it has to be made for Type N. It cannot use the wires and connectors that are made for Type K or Type T or Type S or whatever, anything else. And they may be quite expensive, and they may be quite difficult to get. So in the end, I'm simply going to be hardwiring this into the computer. And, well, not so much hope for the best, but take the inconvenience of one thing being hardwired in. It shouldn't be much of a problem anyway. Okay, one last thing is I've got this little guy. Okay, this is a mini XLR connector, if I'm correct. And what this is another locking connector like that. You can't pull it out. And I'm going to be using this for my door interlock switch as well, so I can disconnect it nice and quick and simply. Like another thing is, of course, you want to be using a thermocouple. That's what this is. On the end of this long thin strip is the thermocouple. That is going to be your temperature measuring probe. This is a Type N thermocouple, grounded junction, and 1.5 millimeter diameter. I wanted to get a thin one because the thick ones, they take a lot of time to respond to minute changes in temperature. A thin one should respond really quick. Okay, and of course it's got the cable at the end and two split ends. Do not mix up the plus and minus. Alright? The red one, the pink cable, this one, okay, the right hand side one, this is the plus and the white one is the minus. Do not mix them up. If you mix them up, you're gonna get a wrong temperature reading effectively. So you want to make sure you take extra care when wiring this into your computer, which is right there, and is the next thing we're gonna be talking about. And then there's this. Okay, this is what's called a PID controller, and this is effectively the brain of your kiln. What this is going to do, you set a temperature to it. Okay, it measures through the thermocouple I just showed you whatever temperature is inside the oven at the moment, and if the temperature is lower than what it's supposed to be, it's going to switch the heating elements on. Okay, after some time it's going to switch it off, try again, and if it's still low, it's going to switch them back on again. These can get these are quite advanced, I must say. I mean, you can set up this particular one to ramp up the temperature to over a period of time, and it can perform ramping, soaking procedures, as well as slow cooling of the oven as well. These are really quite advanced little things. Okay, this is an Omega CN 7800. This is the model number of this particular thing. Okay, so if yours is different, do not follow any instructions to I give to you, and follow the manufacturer's recommendations that you should have gotten with your computer. Last but not least is this effective. This is just a box that I'm going to be using to put all the components you just saw. We have some screws inside, so they're rattling about. I'll be using this to put all the bits and pieces and the cabling and the connectors and the switches and everything else inside of. Okay, I think this actually might be a tad too big. It's very difficult, at least for me, to gauge your dimensions just online. I've got this off of eBay as well. That was the cheapest place I could find it. If you can get a metal one, get a metal one, because guess what? It's not going to melt. I would try to make sure that this is not mounted directly onto the wall of my kiln, because I'm just a little bit cautious of it, well, melting in the heat. Okay, like I said, the skin of my oven shouldn't get really hot, but just in case. Okay, it's never bad to be sure. And the last thing we're going to be needing, certainly last but not least in the very case, this is the thing that does the actual work. These are and they make a hell of a rattle. These are your heating elements. Now you've got two options. You can either buy them pre-wound, effectively like these ones over here, or you can wind them yourself. I don't really recommend winding them yourself unless there's no other option, really. Okay. I got these of a company called Kinetica CNC. I'll try to put their link into the description. The chap on the phone was very helpful and helped me design these over the phone, which was as difficult as it may sound. And these particular ones, I've got two, as you can see. Okay. I've got two, one for each side of the oven. Okay, and we will be routing a groove in the bricks to make sure we can actually put this in there. Yes, it is 1.6 millimeter cantle wire. Okay. The outside diameter of this particular thing is 13.8. These are made. The alloy that they are made from is called Cantle A1, and that is ideally the alloy you want to be using because it is made specifically for this. Really, I can't stress this enough. Do not get the cheap elements you find on eBay. At the moment of me recording this video, the eBay is chock-a-block full of them. The reason why I say not to get them is because they're made of very, very thin wire that is probably gonna burn off the second you actually turn your heating elements on. They are very low quality. So unless you need it for a one-off operation of some description, really don't get them. You're gonna regret it. Okay. These cost about 40 quid, and they look first class, to be honest with you. They are very evenly wound and everything else, and the chap over the phone was really helpful and tried to give the best customer service he could. So this is it for this video. I'm trying to keep them a bit shorter now. We have overviewed quite a few parts of that we're going to be using, the majority of them as a matter of fact. And in the next video we will be talking about the mathematics we will need to put everything together. As well as, if we have time, we will talk over the schematics of the control box as well. So until next time, have a lovely day and take care.